you will see logarithm problems on both the SAT and the ACT. The ACT ones tend to be a little bit more straightforward, where the SAT can be a little bit more complicated sometimes. So what I want to look at is first the form. What do logarithms mean? So you may have never seen them, or maybe you saw them but it's been a while. So let's take a look at how we get from, we take an exponent form, as in right here where it says b to the p equals n, where b is your base, and then p, well, that's the power or the exponent, and then n is the number that equals. And then for the logarithmic form, what we do is we change the order of these things. We bring in the word logarithm, and then a little bit lower than the word log, I write the b for the base. Then I write this n here for the number equals the p, the power. So, this video, we're not going to deep depth on relearning the whole thing. A lot of times just knowing what I'm going to show you is sufficient to get the problem right. So I'm going to refer back to this logarithm exponent model, but basically we can express something in exponent form or logarithmic form. So here's an example. Here is the exponent form, right? So we have base, the base to some power equals a number. So for example, I could have 5 be my base, to the second power here, the exponent's 2, equals 25. Now that's true, right? 5 squared equals 25. Here I'm just showing you how they can switch from one form to the other. Now this whole expression, 5 to the second power equals 25, we can write this and we call logarithmic form by we write the word log. We don't write the whole logarithm, we just write log. And then a little bit lower than the word log, we put the base. Recognize this? See, the 5 over here was the base. So I'm going to put the base right here. Then next, what I have log, we can say log base 5, 25. That was the number that it equaled. Okay, 5 log base 5, 25, and then the power, notice the 2, that was the original power or exponent. Okay, so I like to look at it like this. When I see log form, what I do is I'll look at this base, and that's 5, and then this means right here 5 to the power of 2 equals 25, right? I could go back to this form. You really can go back and forth. So let's take a look at how they might ask you in a fairly straightforward question. And again, sometimes just knowing this is enough to get the answer right. So this one, it reads log base 3, 9 equals x. And they want to know what x is. So this is where I use this sort of what I call loop method, where I look at the 3 to the power of x. Okay, so 3 to the power of x equals that 9, And again, a lot of times I'll give you straightforward ones like this where you can see, well, 3 to what power is 9? Of course, 3 squared is 9. So now we know that x is 2. Taking a look at something similar, but we've got a base of 3 here, log base 3, 1/3 equals x. So what power, what I want to do is I want to go 3, I'm going to take that 3 to this power, the x, so right here, 3 to the power of x equals 1/3, Now this may not be as obvious, but you need to make sure you know this. Notice how we have 3 to a power equals 1/3. Well, really what it is 1/3 is sort of the reciprocal or flipped. The 3 is flipped. So what it really is 3 to the -1 power gets you 1/3, right? Anything to the negative power is going to flip it. So example, if it had been 3 to the -2, that's 1/3 squared, which is 1/9. So now getting a little bit more complicated here is we need to know about, we've already talked here about if you have something like 3 to the negative 2, then that's 1 over 9. Okay. Going into the powers, when we have a fraction, just know that 3 to the 1/2 would mean square root of 3, or 9 to the 1/2 means the square root of 9, which of course is 3. So they could ask you to find x. They could say x here as the base. They could have this equal 1/2, and they could say 4. So what am I going to do here? Well, what I need to do is remember my little simple loop technique where I say x is the base. I'm going to say x to the power of 1/2 equals that 4. So you have x to the 1/2 equals 4. You need to remember that anything to the half is going to mean we're doing a square root. So why don't I rewrite this x to the 1/2 as the square root of x equals 4. Now you may be able to visualize this as 16, but you could always square both sides. The square cancels out the square root, and I get an x is equal to 16. So definitely make sure you know your negative exponents, your fractional exponents, and you'll be able to get a lot of these problems right.